Assalamualaikum and a very good morning to Dr. Zahari, our lecturer for fuzzy set theory, Maths 633. So today our group, the team members consist of KHAIRUL NIEZAM bin ABDUL AZIZ, MOHAMMAD WAFIYUDDin bin ABDUL MUTTI, NURUL AINA SYAMILA binti Muhammad IZAHAR, and me myself, NURUL binti ARIFFIN. We are from CS 2905A. So today our report or our presentation is about classification of household group based on income and number of dependents. So for the abstract, this study aims to develop and test a fuzzy inference system for categorizing household income according to factors like income and family size. Considering poverty requires an awareness of household income and expenditure, although essential income is hard to quantify because it encompasses monetary and intangible aspects. Thresholds for low, middle, and high income are typically chosen to suit the studied demographic. So for introduction to fuzzy set theory, Zadeh invented the fuzzy set theory in 1695 to broaden the traditional definition of a set. Zadeh presented a new mathematical method to make decisions with uncertainty in mind. The concept of the fuzzy set, which lacks strict boundaries and may contain component only partial or fuzzily, serves as the theoretical foundation for these approaches. So the degree to which an element belongs to a fuzzy set is calculated using appropriate membership function. So we move to the part A. So for introduction, the problem statement is initially the classification of the household group is based on income. So the classification was very general because there were families with many dependents. However, they were classified as M40 because of the total income. Therefore, the classification of the household group should be based on income and the number of dependents in the family. The number of dependents in the family may influence which group they are being placed in. So for the objective, we propose and we validate the fuzzy inference system of classification of household income based on income and number of dependents. For significant and project benefits, the significance of this study is to give exposure to students about the fuzzy inference system. Unknowingly, there are many things around us that are closely related to fuzzy inference system. Without our consent, income and amount of dependent or number of dependent can also be measured through fuzzy inference system. We determine the salary of a household by comparing income and total dependent of a family. This is very important to determine their group in today's society. Furthermore, the benefit is that it will help students to better understand and know how to use fuzzy inference system, and knowing that using fuzzy inference system, students are also able to classify family groups in Malaysia. Therefore, it is clear that this fuzzy inference system is not a loss for students to learn because it provides good benefits without realizing it. For the conclusion, we will use the fuzzy inference method to complete our project titled Classifications of Household Group based on income and number of dependents. By using inputs such as income and number of dependents, it will produce output that determine whether the family group is B40, M40, or T20 in different levels. This project will help us to complete and make a comparison with the existing classification of household, whether it is relevant or not with the progress of the work. So we'll continue with part B.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad WAFIYUDDin bin ABDUL MUTTI, and we will proceed to the part B, which it will lead to the methodology. First, we will go to the four main components. First one is a falsifier. Falsifier has four formula that will involve the membership function. The first one is singleton falsifier. The second one is Gaussian falsifier. The third one is triangular falsifier, and the last one is trapezoidal falsifier. All of these functions will make the membership function. Next, we will go to the fuzzy rule, the second one, which is fuzzy rule based. It has 5 rules, which will involve the partial if-then rule, single fuzzy statement. The single fuzzy statement is the y is b power of k. The if part is omitted, while the or rule the other rule is or rule. The fourth one is the gradual rule. The smaller the x, the larger the y. And the last one of the rule is the non-fuzzy rule. It conventional if-then rules. The third one is fuzzy inference engine. Composition-based inference. In composition-based inference, all rules in the fuzzy rule base are created into a single fuzzy relation. Fuzzy if-then rule in universal using. It has two methods which will involve Mandani combination and Zadev combination. The formula you can see in this slide. Next, we will go to the individual rule-based inference. In individual rule-based inference, each rule in the fuzzy rule base produce an output fuzzy set. This means that if a fuzzy rule base consists of P rules, then P output fuzzy sets are produced. It is also involved two formulae which will involve combination by fuzzy union and combination of fuzzy intersection. For the last one is for the methodology for the four component is defuzzifier. The first one is central. It has four formulae too, and the first formula is centroid method. Centroid method. It is also known as center of gravity method. This method can be applied to any fuzzy set. This method will integrate both sides. Will integrate the uh, numerator and denominator. The second formula is weighted average method. This method needs each membership function involved to be symmetrical. The third one is maximum membership principle. And the last one is min-max membership principle. Now let us proceed to the frame of inputs and outputs.
Assalamualaikum warahmatullahi wabarakatuh. My name is SYAMILA binti MOHAMMAD IZAHAR. So for our framework of input and output, we actually have 7 steps to complete this project. So for the step 1, we need to identify the input and output linguistic variable, their linguistic value and range. So as you can see, our input have two variables, which is income and number of dependent. Income is divided by 3, which is low, medium, and high. Same goes to number of dependent. So for the output, we have 4 outputs, which is classifications of the household group, level B40, level M40, and level T20. So for the classification of the group, we divide by 3, which is B40, M40, and T20. While level B40, we divide by 4, B1, B2, B3, and B4. Same goes to level M40. So for the last one, level T20, we divide by 2, which is T1 and T2. So for the second step, we construct the membership function for each input and output linguistic variable. As Dr. can see, this is our membership function for income, which are low, medium, and high. So the next, this is the graph of income. Next. Okay, so this one is the membership function for number of dependent. Same goes to income. We have low, medium, and high. Next. Okay, this one is our output membership for classification of the household group. We has low, medium, and high. Okay, so this one is membership for level B40. We have B40 B1, B40 B2, B40 B3, and B40 B4. Okay, so this is our membership function graph of level B40. Next. So this one is membership for level M40. Same goes to B40. We have M1, M2, M3, and M4. Next is our graph of level M40. So the last output is membership for level T20. We have membership of T20 T1, T20 T2. So for the step, okay, next. So for the step 3, we set up a fuzzy rule base, which is we have 11 fuzzy rule base. Next. So for the step 4, we convert crisp data into fuzzy data set using membership function. So during the fuzzifications process, numeric input variable are converted into their corresponding fuzzy set membership function. For example, the membership value for income in fuzzy set low when we let x equal to 4,250 as below. So when we put in the formula, the output will be 0.5. The membership value for income when x is equal 400,250 in fuzzy set medium as below. So when we put the value for 1,250 in the income in the medium level, so we get the 0.1. For variable percentage of income at 4,250, we choose a fuzzy set low since it has the highest membership value. So for the step 5, we evaluate rules in the rule base and combine result from each rule. So we choose 0.5. So we let X be the income, Y be the number of dependent, Z1 be the classification of the group of household group, and Z2 is the classification of the household group with the level of the classification. Okay, suppose the X equal to 4,250 and Y is equal to 7. With the combination of these two fuzzy input with the fuzzy rule base, it can be illustrated that as below. So this actually have intersection. Okay, the next slide. So actually the intersection is below 0.5. So this is our calculation, which we convert output data into non-fuzzy value. So this calculation is using by centroid method. So the final answer we got 541.797. So the next is step 7 that will be presented by Wafi.
Okay, now let us proceed to the step 7, which will involve the implementation in MATLAB Fuzzy Toolbox. There are 5 editors from MATLAB that we'll use in fuzzy inference system. The first one is Fish Editor. Fish Editor is used to design fuzzy system logic. It will display the general information about inference system about the fuzzy inference system. Okay, next. The next one is Membership Function Editor. This editor will define the membership functions for input and output for the fuzzy inference system. It will display the edit output and input of the membership function. Okay, so this is the input from the membership function that we will use. Next. And this is the output that we use in MATLAB. And this is also the output. Next. This is the output. Okay, next we will go to the rule editor. For the rule editor, it will define all rules for fuzzy inference system and choose the connections for input variables such as and or. For an example that NURUL AINA SYAMILA has said that we have 11 rules. So we get the 11 rules from this MATLAB, this editor. Okay, next we will go to the rule viewer. If we put the value in all input variables, the editor will give the result of output variable. Okay, next. Okay, for the last one is the surface viewer. It will generate the 3D surface from input variable, which is income and the number of dependent, and output variable, such as classification of household group. I think that's all from me. Now let us proceed to the results and findings.
Okay, so results and findings. The calculation by using weighted average method. So as you can see, the formula given that where summation denote the algebraic sum and Z2 is the center of each symmetric membership function. And with the substitution of the value, we got 250. The calculation maximum membership principle, also known as height method, is limited to a peak output function. For example, the max membership value is located at a single point. Based on the figure 8, the answer is 1. The calculation of mean max membership principle, also known as middle of maxima, also that given at the formula below. The method is also known as middle of maxima, as the max membership value is not unique in an interval as compared to the height method, and the answer is also 250. Next. So we continue with inferences process for B40. So if you can see that the income shows that it is 1,890 and the number of dependent is 6. And the group is going to fall at B40 and the level is B2. Next. If you can see the income for 4,000 ringgit and dependent is 1. The classification of household group is B40 and the level is B4. Next. So the inferences process for M40. 6,768 is the income for M40 for medium, and number of dependent in 7 is going to fall at high for the dependent, and the classification of the household group is going to fall at M40 and the level is going to fall at M1. Next. So in here we have 9,000 ringgit for income, which is medium, and dependent at 3, which is in between medium and low. And then the classification of household group is going to fall at M40 and the level is going to fall at M3. Next. The final one is inferences process for T20. So if the income is going to fall at 14,000 and the number of dependents is 6, then the classification of the household group is T20 and its level is going to fall at T1. Next. For income 12,380 and the number of dependents 2, the classification of the household group is going to fall at T20 and the level is going to fall at T2. Next. So for the conclusion, we proposed and validated the fuzzy inference system of classification of household income based on income and the number of dependents. As we went through the processes, the existing classification of household is not relevant nowadays. Hence, with the new calculations, the new household classification fits better for evolution. So I think that's all from us. Thank you.